x. Again, if you feel more comfortable to put a little dot, put a little dot underneath the function. So you don't forget to say times the inner function prime. Okay, so we differentiate. So the left-hand side, can anyone help with the left-hand side, please?
Cosine?
Yes, awesome. Excellent. And now we differentiate cosine. When we differentiate cosine, what do we get?
Negative sine.
Negative sine y times the inner function prime.
Dy over dx.
Excellent. Equals 2x prime
Over 2.
minus 3 times the inner function prime.
Dy over dx.
Thank you very much. Now we notice that we have two terms. This one that has the variable and this one that has the variable. These two have to be on one side, and this does not belong there, has to be taken to the other side, to the left. So I have cosine x minus 2 equals sine y minus 3, and already distribute, factor out. So I don't have to write it twice. So these two terms have to be on one side. They both have a common factor. The common factor is taken out. This was negative. It goes to the other side. It's positive, and then minus 3. Perfect. Final form, dy over dx.
Cosine x minus 2.
Exactly.
Sine
Exactly.
y minus 2.
This is our variable. It's multiplied by this. This number has to go to the denominator, and this has to be in the numerator. That's it. Brilliant. Thank you very much. Any questions on this? So what is the difficult part? Well, the difficult part is to get here. Then moving terms around and dividing is just algebra. So I think it's helpful if you put a dot under the function so you never forget to multiply by dy over dx. Okay. Let's choose.
Can we do 19?
19. 19, we have the square root of x plus y equals x to the 4th plus y to the 4th. Perfect. Good. Again, we are asked to find dy over dx, not y prime. I recommend this notation. Okay. We differentiate. We start from the left. We need to refresh our memory on the formula of the square root of a function prime. Square root of a function prime. Ready.
1 over 2 times root x plus y.
Times the inner function prime.
Function 1.
1 plus
1 times dy over dx.
That's it. X to the 4th prime.
4x cubed.
Excellent. Plus y to the 4th. Y being a function. A function to the 4th power prime.
Will that still be 4y cubed?
Times the inner function prime. Please write those few words on a sticky and put it in front of you on the monitor.
Dy over dx.
dy over dx. Please, it's very important. This side is okay for now, but this one is not okay because the variable inside parentheses, I have to distribute this quantity to 1 and I have to distribute it to dy over dx. This to 1, this to dy over dx first. So, I'm on my page 9. So 1 over 2 the square root of x plus y plus 1 over 2 the square root of x plus y times dy over dx equals 4x to the third, 4y to the third, dy over dx. Only now I realize that there are two terms that have the variable. This and this. It doesn't matter now. I can move this one here and then move this one here. And when I move this here, I already factor out dy over dx. This stays as is. But this one was positive, so when I move it to the other side, it will be negative 4y to the third. Now the 4x cubed stays, but I bring this and I have to change its sign because I'm moving it from one term to the from one side to the other. Finally, I am after this. What does dy over dx equal to?
Over the entire right side divided
Over exactly what it multiplies. Exactly. Thank you very much. So I have 4x to the third minus 1 over 2 the square root of x plus y over all this. Please do not be tempted to do anything here. What we can do is find the least common denominator, which happens to be the same. I don't like this method, but you could say, because they are the same, you could multiply by this. So if we do that, then we will simplify it a little bit. So 8x to the third, the square root of x plus y minus 1. And then 1 minus 8y to the third, the square root of x plus y. Any questions? Any questions? So again, what I did here, both top and bottom, I multiplied by 2 the square root of x plus y. I don't like this method, but it works here. When I multiply here, I get negative 1. When I multiply these two, I get this 8x cubed, then the square root of x plus y. And when I multiply here, I get 1. And when I multiply these two, I get 8y cubed, the square root of x plus y. This is okay. This is okay. Okay, so let's share the screen again and take a look. I like to look at one with a tangent. Use implicit differentiation to find the equation of the tangent line to the curve at the given point. So let's also work on one of these. Did we get the idea? Are we okay with implicit differentiation? Are we okay with implicit differentiation? Anyone?
Yes.
Yeah.
Okay. I like to do everything very slowly, but at the same time, we have to finish, right? So if we need more examples, you can always, please, I'm begging you to do the work in WebAssign, and I'll help you finish it up. So let's choose a problem in which we have to also determine the equation of the tangent line to the graph of the given curve. Any preference, or I will pick?
20.
We want to work on 20. 20? No, I
Oh,
mean
wait.
27
No.
through 36.
I'm sorry. I meant to say 30. I'm
Okay.
sorry.
30 is a good one. Let's. Very good. So we have y squared 6 minus x equals x to the third, and the point is 2 the square root of 2 comma the square root of 2. Okay. In this situation, I will definitely use the rule of simplifying and making my life easier. We'll distribute. If you can say, well, maybe you want to just differentiate as is. That's fine too. Okay, let's differentiate as is. I would have distributed, but then I have to apply the product rule twice. Doesn't matter. Okay, so y squared prime y squared prime
2y times dy over dx.
times the second one plus y squared times this prime
-1.
excellent, and we differentiate the right hand side.
3x squared.
3x squared.
Perfect. Awesome. Good. So it happens that this equation has only one term that consists or has the variable. So I'll have 2y 6 minus x dy over dx. This is negative y squared, but it will become positive to the other side. And then I solve for dy over dx. And yes, you already told me it's this over this. So 3x squared plus y squared. I will distribute now 12y. You can say you just told us not to distribute the factors in the denominator. True, but I'm going to plug in something. You don't have, we don't, I will distribute only because it's easier to plug it in, but otherwise I will not. So 12y and then minus 2xy. And now I need to determine the slope. But which slope? The slope at this point where x is 2 and y is the square root of 2. So I'm going to write a wrong bar and say right here x equals 2 and y equals the square root of 2 and continue. So 2 squared is 4, 4 times 3 is 12, plus the square root of 2 squared is 2. 12 times y is 12 the square root of 2, minus 2, and then I multiply these two, so times 2 the square root of 2. I continue. 12 plus 2 is 14. Here I have 12 the square root of 2 minus 4 the square root of 2. So this is 4 the square root of 2. 12 apples minus 4 apples is 8 apples. I will simplify by 2. I have 7 over 4 the square root of 2, and I will also rationalize by the square root of 2. So the numerator is 7 the square root of 2, and the denominator is 4 times 2, which is 8. So this is the slope of the tangent at the point 2 comma the square root of 2. Because they're asking us to find the equation, then I have y minus y1 equals the slope times x minus x1, where this is the slope. x1 is 2, and y1 is the square root of 2. Let's look at this for a moment and then plug it in, because we have to try to simplify a little bit. So first, we differentiated both sides. We solved for the derivative. And then we plugged in these numbers, x equals 2 and y equals the square root of 2. When I calculated everything, I got this. This is the slope of the tangent line at the given point. To find the equation, I have to use the formula y minus y1 equals the slope times x minus x1. And I plug this in, and x1 is 2, and y1 is the square root of 2. Any questions before we continue? We haven't finished, but I want to see if you have any questions. Any questions?
No.
Okay, then, so let's put them in. So y minus the square root of 2 equals 7 the square root of 2 over 8 and x minus 2. I have to distribute. So 7 the square root of 2 over 8 times x minus, when I distribute here and simplify 2 with 8, I have 7 the square root of 2 divided by 4, but I have a negative the square root of 2 that goes to the other side as positive the square root of 2. So here I have to find the least common denominator, which is 4, and I need to multiply this by 4. Negative 7 apples plus 4 apples will be negative 3 apples. And then 7 the square root of 2 over 8x. And this is, yes, it's very weird, but it is what it is. This is the equation of the tangent line to the graph of this at this point.
Can we go back for a second? I got a little confused.
So I
No,
replace this by the square root of 2, this by 2, and then this by 7, the square root of 2 over 8. Is this okay?
That's okay. Where I get confused at is where we have the 7 square root of 2 over 4. How do we bring that back?
So this times this is this.
Right.
This times 2, I simplify and I get 4.
Okay, sorry.
No worries. And then this goes to the other side as positive the square root of 2. So when we multiply these two, I have to simplify the numerator, which is 2, with the denominator, which is 8. So I get a 4 here. And then when I bring the square root of 2, I have to combine these. I have to add them. Add, subtract, it doesn't matter. This is negative 7 the square root of 2, and this is positive 4 the square root of 2. Negative 7 the square root of 2 plus 4 the square root of 2 is negative 3 the square root of 2 over 4. This is the equation of the tangent to the graph of the given whatever this is at this point. Is this okay?